Right now, 60 meters beneath the surface of a megacity, a $100 billion subterranean war against physics is raging. A silent but deadly groundwater pressure of 600 kilopascals is threatening to crush everything in its path. This is a catastrophic hydrostatic force capable of snapping heavy carbon steel beams like fragile twigs.
We are standing inside one of the largest infrastructure projects in the country. The engineering on display here using high-grade...
This isn't just a tunnel, it is a colossal 50 million cubic meter survival bunker for an entire metropolis. To comprehend this scale, picture tens of thousands of massive industrial reactor tanks buried alive in the bedrock. This megaproject presents an unprecedented nightmare in modern fluid dynamics and geotechnical engineering. The core infrastructure demands a continuous 100-kilometer subterranean void, boring through the most unpredictable geological strata. With an internal diameter of 15 meters, the sheer volume of this cavern requires absolute structural perfection. To withstand the crushing subterranean pressure, the concrete shell must be forged to a thickness of 0.8 meters. Engineers are utilizing an ultra-high-strength 80 megapascal concrete mix, pushing the absolute limits of material science. The first extreme engineering hurdle lies in manipulating the brutal forces of fluid dynamics.
This section here, it's failing. We need to initiate the bypass sequence now.
Reroute the pressure valve immediately, or this whole line goes.
Do it. I'll prep the conduit.
The answer lies in gravity. The entire 100-kilometer tunnel is calculated with a precise 1% gradient. This microscopic angle harnesses the kinetic energy of gravity, creating a relentless, self-sustaining flow. To pierce the primordial lithosphere, engineers rely on the TBM Titan of mechanical engineering, weighing 4,000 tons. Measuring the length of 3 football fields, this machine is a mobile, automated manufacturing plant buried deep underground. At its heart lies a massive 6-meter diameter cutter head, forged from high-strength monolithic carbon steel. 80 specialized tungsten carbide discs are strategically distributed across its surface, built to withstand extreme thermal friction. As the 12,000 kilowatt electric drive motors roar to life, they generate a colossal torque against the rock face. Each tungsten carbide disc endures an axial compression force of 30 tons, pulverizing dense clay and limestone. But breaking rock is only half the battle. The real nightmare is preventing a total structural collapse. At 60 meters deep, the weight of the city and the crushing groundwater are constant threats to the excavation void. The solution is earth pressure balance technology, ensuring the excavation chamber is never left empty. Excavated soil is mixed with specialized polymer foams to create a pressurized, plasticized slurry. Optical sensors and hydraulic gauges monitor the subterranean pressure thousands of times per second. The goal: maintain an internal counterpressure that exactly matches the staggering weight of the earth above. Any delay in pressure compensation, even by a few kilopascals, could trigger irreversible urban subsidence on the surface. Directly behind the grinding cutter head, a microscopic assembly process is occurring with watchmaker precision. As the TBM advances 2 meters, it leaves behind a vulnerable, raw earth wall that must be sealed instantly. In the shadow of the grinding cutter head, a high-stakes robotic ballet is unfolding in the assembly chamber. Every 2 meters of forward progress creates a dangerous gap that must be armored with precast concrete segments. These aren't ordinary blocks. Each segment weighs 15 tons and is forged from high-density reinforced steel. A 6-degree of freedom hydraulic erector arm must lift and position these monoliths in a cramped, dark environment. The machine operates amidst intense vibration, high heat, and a constant rain of industrial dust and grease. Laser guidance systems and 3D coordinate sensors continuously recalibrate the robotic arm's trajectory. Every movement is a battle against the Earth's natural tendency to reclaim the void we've carved. The assembly tolerance is set to a brutal maximum of just 2 millimeters. For a 1.5-ton industrial component, this level of precision is virtually unheard of in heavy construction.
The key innovation lies here. This seemingly minor 2mm gap is critical for the structural integrity of the entire tunnel system.
Each segment is locked into place using massive axial steel bolts, creating a continuous, rigid armored ring. To defeat the 600 kilopascal water pressure, every joint is sealed with multi-layered vulcanized neoprene gaskets. Under the massive thrust of hydraulic jacks, these gaskets deform and fill every microscopic void. This creates a perfect hermetic seal, isolating the subterranean city from the crushing pressure outside. Cycle after cycle, boring, balancing, and lining the machine relentlessly builds the metropolis's new backbone. Beyond the 100-kilometer tunnel, deep within the primordial basalt bedrock, lies a cathedral of mechanical power. This is the terminal pumping station, an underground vault designed to hold the line against an ocean of floodwater. Bathed in high-intensity halogen light, the station's scale is breathtaking, with cold steel walls echoing with mechanical humming. At the core of this complex are 4 massive centrifugal subturbines, forged from corrosion-resistant nickel-chromium alloy. Thick, high-voltage copper cables, 20 centimeters in diameter, snake along titanium racks to power these behemoths. Each turbine boasts 14,000 horsepower, connected to a vertical drive shaft 1.5 meters thick. The scream of magnetic inductors and the mechanical resonance of the startup sequence vibrate through the air. At full throttle, this system can discharge 200 tons of water every single second. This massive kinetic force is equivalent to dozens of rocket engines, creating a planetary-scale hydraulic regulator. But before this Titan can be commissioned, it must endure a sequence of brutal, limit-testing trials. The survival of 15 million citizens above depends entirely on the absolute integrity of this structure. The stress test sequence begins by sealing the system with massive 500-ton carbon steel floodgates. These gates are driven by multi-stage hydraulic cylinders with bore diameters of up to 2 meters. Millions of tons of water are then pumped into the system at 150% of its maximum design pressure. Optical sensors along the tunnel walls record every micron of elastic deformation in the reinforced concrete shell. At the peak of the stress test, safety valves scream as they vent high-pressure steam with a deafening mechanical roar. This is a moment of truth, witnessing the massive infrastructure straining against unprecedented physical loads. Simultaneously, an absolute quality control protocol is initiated across the entire 100-kilometer network. Fleets of autonomous rovers equipped with X-ray flaw detection systems crawl along the tunnel's inner lining. They scan 100% of the critical weld points and analyze the structural density of every neoprene gasket. At 600 kilopascals, a void the size of a needlehead could trigger a catastrophic hydrodynamic tear. Artificial intelligence algorithms analyze the scans in real time, searching for micron-level cracks or air bubbles. Any anomaly, no matter how small, triggers an immediate automated repair sequence in this steel labyrinth. The project is more than a drainage system, it is a declaration of human engineering dominance over nature. It establishes an ultimate physical shield, neutralizing 100% of the flood risk for the urban core. This stability guarantees the absolute protection of other critical underground infrastructure networks, from automated robotic logistics chains to high-speed fiber optic arrays carrying petabytes of financial data. This is the grand inheritance of the Roman sewer systems, an evolutionary leap in civil engineering, a testament to humanity's ability to shatter the physical limits of modern technology and survive. If you are passionate about the absolute power of machines, subscribe to explore our next mega project. Beneath the skyscrapers, this concrete labyrinth also serves as a high-speed artery for automated logistics. Robotic freight platforms glide silently on magnetic rails, bypassing the gridlocked traffic of the surface world. This dual-purpose infrastructure ensures that the city's supply chain remains indestructible during the worst superstorms. The heat generated by these massive operations is captured by a specialized geothermal heat exchange system. Vast arrays of heat-conductive pipes snake through the tunnel walls, recycling thermal energy back to the surface. This is a closed-loop engineering miracle, turning a subterranean void into a sustainable energy source. Every cubic meter of space is optimized through AI-driven structural health monitoring. Fiber optic strain sensors embedded within the concrete detect shifts as small as a single micrometer. This allows engineers to predict and prevent structural fatigue decades before it occurs. The tunnel's interior is coated with a hydrophobic, self-healing polymer to prevent chemical erosion. When floodwaters arrive, the surface tension of the walls accelerates the flow to its maximum theoretical velocity. It is a violent, controlled river contained within a cage of high-performance, reinforced steel. Maintenance is performed by autonomous drones that traverse the 100-kilometer network in total darkness. Equipped with LiDAR and multispectral cameras, they ensure every seal remains hermetic. We are looking at the ultimate insurance policy for the modern age, a silent titan protecting our future. When the storm of the century hits, the central AI subbrain takes absolute control of the metropolis. Satellite data and surface sensors trigger a massive intake sequence, opening the primary vortex shafts. Thousands of tons of water begin to plummet 60 meters down, transformed into a controlled vertical cataract. To prevent structural erosion, the impact zones are armored with sacrificial high-density basalt plates. Inside the main artery, the 1% gradient kicks in, accelerating the flood to 15 meters per second. This is a terrifying wall of kinetic energy, generating enough force to crush anything but these concrete walls. The air pressure ahead of the flood wave is vented through specialized high-velocity blow-off valves. Deep in the control center, engineers watch as the system reaches 90% of its total 50 million-ton capacity. Hydraulic vibration sensors detect the rhythmic pulse of the massive turbines preparing to engage. The 14,000 horsepower motors ignite, their magnetic fields humming with a power that can be felt in the bedrock. This is the moment of peak mechanical stress where material science meets the unstoppable force of nature. The automated floodgates adjust their aperture by fractions of a degree to optimize the laminar flow. Every joint, every neoprene gasket is now holding back a pressure equivalent to 60 tons per square meter. The silence of the underground is replaced by the primal roar of a civilization fighting for its survival. It is a masterclass in extreme hydraulic management, preventing the surface city from becoming an ocean. As the storm subsides, the AI subbrain initiates the post-flood evacuation sequence. The four 14,000 horsepower turbines ramp up to their maximum RPM, purging the remaining 50 million tons of water. An automated scouring sequence uses the final surge of water to strip away silt and debris from the tunnel floor. High-pressure nozzle arrays embedded in the ceiling deploy, spraying a self-cleaning polymer to decontaminate the concrete. Within hours, the roaring subterranean river is replaced by a pristine, silent industrial corridor once again. Maintenance rovers re-emerge, their X-ray sensors confirming that the 80 megapascal shell remains flawless. This project is the ultimate victory of engineering logic over the chaotic unpredictability of a changing climate. A 100-kilometer concrete promise that this megacity will never be swallowed by the abyss. It stands as a modern megalith, a subterranean cathedral built not for gods, but for the survival of millions. The success of this system defines the new standard for global urban infrastructure in the 21st century. As the surface city wakes up to a dry, safe morning, the silent titan below goes into standby mode, waiting, breathing, and ready to fight the next war against the element. We have conquered the darkness and tamed the flood with nothing but steel, concrete, and human intellect. This is the essence of TechGen Manufacturing, breaking the limits of what was once thought impossible. Join us as we continue to explore the titans of modern engineering. Subscribe and witness the future being built.